Hello friends, today we are going to discuss about pulse code modulation, which is one of the important technique in digital modulation. What is the purpose of this pulse code modulation means? So in order to overcome the noises while transmitting a signal from the transmitter to receiver, there may be a chance to occur the noise in the signal. So in order to overcome that, we are going for the pulse code modulation, so which is a digital modulation techniques. So in this pulse code modulation, there are two important sections. First one is PCM generator. So it has four important components. First one is low pass filter, second one is sampling circuit, third one is quantization circuit, fourth one is encoding circuits. Let us discuss one by one in detail. Here the input signal is denoted as x of t, and we got the output. At the end of the encoding circuit, we have PCM signals. So what is the function of low pass filter means? So low pass filter allows only low frequency and it attenuates high frequency components. This is the frequency response of low pass filter, in that x axis denotes the frequency and y axis denotes the amplitude in dB. So this is the response. So this point indicates the cutoff frequency denoted as Fc. So whatever the frequency we have applied to the low pass filter, it allows up to this cutoff frequency. So after that, this cutoff frequency it does not allow. It means it starts from 0 to Fc, it allows the frequency. That low pass filters, it remove the noises, it means high frequency signals. That means after the frequency Fc, it eliminates that high frequency components and make it as a 0, and it allows the high frequency components and make it as 1. So the low pass filter allows the frequency depends upon the cutoff frequency. Here cutoff frequency is denoted as W or Fc. This low pass frequency signal is applied as an input to the sampling circuit. Then what is the purpose of sampling means? It samples the continuous time analog signal, that is nothing but your voice signal or message signals at a particular instant of time. It means at equal time period. So the time period at this slot to this slot is denoted as t. Similarly, this slot to next slot is same. So at equal instant of time, the analog signal is discretized by using the sampling circuits. So it samples the analog signal into discrete signal. That discrete signal as an input to the quantization circuit. The circuit performs the round off operation. It means suppose we have the 6.9 as a amplitude of the discretized signal at a particular instant. The 6.9 is approximated as 7. Similarly, 7.5 is equal to 8. 7.1 is approximated as 7. So the purpose of quantization circuit is round off the value. It will be as an input to the encoding circuits. Here the encoding circuit is encoded the rounded off signal, that is the quantized level values as a coded values. So based on the quantization values, the encoded output is decided. So here let us consider, for example, 7 as your the quantized level value. So it will be denoted by 111 in binary form. This will be the pulse code modulated signals. Here the pulse code modulated signal is given to the regenerator circuits. These regenerator circuits act as the filter, as well as it regenerates and it generates the shape of the pulse coded modulated signal. So it is in the receiver side. So after reshaping and removing the noise, it is given as an input to the digital to analog converter. This DAC is nothing but a decoder. So what is the main function of DAC is to reshape the whatever the input signal, that is the pulse code modulated signal to the generator, that will be reshaped by the stepped response. It means the nature of the DAC is the stepped in nature, right? Now it is given as the input to the low pass filter. That filter is used to smoothen the slope, the smoothen the edges of the signal. It means it recover the original signal like this from the stepped nature response, and this output is denoted as x cap of t. So whatever the signal we have applied x of t as an input to the low pass filter, similar way we have retrieved that signal x cap of t from the low pass filters, so it should be equal. But what happens practically, x of t is not is equal to x cap of t. It means there is a chance for noise. So it will be denoted as q epsilon is equal to xq of nts minus xn of ts. That is, it will be happen by using the quantization circuits. That is why it is denoted as a quantization error. Next video we will discuss about the transmission bandwidth, and we will discuss about some of the problems, and it will be very helpful to clear the concept very easily. So this is what the pulse code modulation circuits, in that we have discussed two important parts: pulse code modulation generator and pulse code modulation receiver. Thank you.